Okay, perfect. Okay, good afternoon.
Good afternoon.
Good afternoon. Okay, perfect. So, we have all the participants. No, they are leaving. Why are you leaving? Okay, okay, perfect. So, now we have six participants, perfect. So, we were speaking first about acids and bases today morning. We have to continue the slides and then we will go far for stoichiometry and chemistry. So let me first get the PDF. Mm, okay. Okay, thank you guys. Thank you. I'm gonna share the screen. Okay. So we spoke about acids and bases and we reached the end about buffers, about bicarbonate. Yeah, we reached here. So I was speaking about the reverse reactions that happens in our body. And as we said that biologically any buffer in our body is bicarbonate. So bicarbonic acid. So the reverse reactions that you have are so water and carbon dioxide, they give carbonic acid, and then the carbonic acid can give hydrogen ions and bicarbonate, and then hydrogen ions and carbonate. So they give these reactions react according to how much we have hydrogen ions inside the solution. If inside the blood we have high amount of hydrogen ions, if here we have the reactants. If we go for chemistry, let's work on this chemically and then we speak biologically. So chemically, according to Le Chatelier's principle, we know that when we increase the concentration of the reactants, what happens? The reverse reaction will start to decrease the concentration of the reactants for them to go to the other side. So if we have a high amount of H plus ions, we have it already high, this reaction, this reverse reaction, will go to the left because it will try to decrease the balance of the buffer, will try to decrease the hydrogen ions. And in this way, you have to think of it. When we have so much concentration of something, either protons, either hydroxide ions, any kind of a reactant in a chemical reaction which is increased in concentration according to the Chatelier's principle, it will start to decrease depending only if it was a reversible reaction. So here, as we said, that when we have a high H plus with with the carbonic acid, it will start to increase the with bicarbonate ions. It will start to increase the carbonic acid, and vice versa. If we have high carbonic acid in blood, it will start to increase the um, protons or the hydroxide, um, the hydrogen ions, and the bicarbonate ions. So it just depends on how much do we have protons, how much do we have, how much is the blood pH acidic, how much is the blood pH basic. It just depends on the blood. The moment that our blood have high amount of H plus ions, this means that the pH is acidic. So it will, the buffer system itself of bicarbonate inside the blood will start to change it and to try to regulate it in a way to be able to make a balance between the two parts, the two reactions. And of course, we don't forget that this reaction is reversible reaction. And of course, if we have so much carbonic acid in blood, so what happens? This carbonic acid starts to try to dissociate into water and CO2 to be able to occur the buffer system inside the blood. So I think now it's more clear. Just write this equation in case. And I'm gonna go back to the questions. We solved them about the pH, the acids and bases, and then we will start with the chemistry. So now biology questions, acids and bases. Okay. So number 20. Oh, the screen is not shared. One moment. Okay. Perfect. So acids and bases. In Imat 2023, question 35, a solution with a pH of 3 is neutral, slightly acidic, slightly basic, strongly acidic, strongly basic. So of course, pH is 3. This means that the pH is so low. This means it's acidic. But if you compare between 3 and 7, there is a very huge distance between them. So this means it's strongly acidic. So number 25, it's strongly acidic, C. And of course, to solve this question, of course, you should walk on the axis, much easier. 2022, which of the following is true about bases? They donate hydrogen ions in water. They increase the concentration of hydroxide ions in water. They have a pH less than 7. They turn blue, litmus, paper red, and they are proton donors. So normally bases, they increase the concentration of hydroxide ions in water because, as we said, that bases usually, let's say strong base like NaOH, Na plus, OH minus, when these ions, they dissolve in water, which is solvent. So when they dissolve, they dissociate, and when they dissociate, so much OH minus will be dissociated in water, and that's why we said that it increases the concentration of hydroxide ions in the solvent or in water. And 27. 27. Okay, buffers are substances that help maintain constant temperature in organisms, constant pH in solutions, constant pressure in systems, constant osmotic balance, or constant salt concentrations in cells. So as I have been speaking from the beginning of the acids and bases, I have been saying that buffers does not change the pH, but they just try to maintain the acidity and the basicity. So this means that they help maintain the constant pH. They try to make always the pH in a constant way. So it's B. 28. A buffer system in the body helps to maintain constant pressure, stabilize pH, increase temperature, um, reduce osmotic pressure, enhances aromatic reactions. This is mainly the same question which as before, but they try to play on the question or ask it in a different way, but it's the same. So stabilize the pH. Stabilize means make the pH constant, which is the same. Which of the following is true about acids? They increase the pH of a solution, they decrease the concentration of hydrogen ions, they release hydrogen ions in water, they are proton acceptors, and they turn red litmus paper blue. So usually acids, they release hydrogen ions in water. As we just said, any acid, let's say HCl. So which is an acid, H plus, Cl minus, and they dissolve in water, H plus will be there. The pH of a solution is a measure of its hydrogen ion concentration, hydroxide ion concentration, salt concentration, solute concentration, and solvent concentration. So, of course, HPH means hydrogen ion concentration. When we see the pH, P means minus log, means the different sign of log of the concentration of H plus. If we said POH, P means minus log, so means minus log concentration of OH, H minus here concentration of H plus. So when we have anything that starts with P, let's say pKa, pH, POH, all of these means the moment you see a P in chemistry means minus log. And then you know the concentrations, and we're done with the questions. Okay. Now I think we're gonna start with stoichiometry in chemistry. I just want to see if you have any questions. So just give me 1 second. Oh, there's someone in chat. B, okay. So, do you guys have any questions? Is there anything you have doubts about, you didn't understand? Okay, I'm gonna now prepare the PDF of chemistry. Chemistry. Second. Okay. Does buffer have any effect on enzymatic activity? You mean like to accelerate the reaction, or in what way do you mean? Like on what stage? Like, because enzymes, they usually accelerate the reaction. Buffer, it balances the pH, it makes it constant. So, and on what sides, on what levels? Okay, so let's start in the chemistry. If you have, when you respond, like I'm gonna respond when I finish the chemistry, okay? So, are you on screen share or not yet? Does tag maintaining pH on which enzyme works best? Um, Look, I think it can, I think, but I'm not sure. Yeah, exactly. In erythrocytes. Yeah, exactly. Bicarbonate, it's in blood on erythrocytes. Um, it can have it can have an effect, a good effect on enzymatic activity, and just like its main work is to maintain the pH, the constant pH, and um, it might allow the enzyme to work effectively. It might allow the enzyme to work in a good um, like in a good nature effectively, because if there was no buffer, there was no balancing between the base and the acid nature or the acid medium. So here the enzyme would be in a nature which it cannot be working in a good function. So if there was no buffer, there's no working a good working of an enzyme, you know. So if the enzyme it only works in an acidic medium and there was or in a neutral medium, let's say, and there was no buffer system, it wouldn't allow it to work. So yeah, I think yeah, it does have an effect because without the buffer, no, like the enzyme won't work in a good nature, which it can be working, because like so much enzymes they only function in one medium, let's say like pepsin, or like any kind of gastric enzyme, they just function in a medium which is so acidic, like from 2 to 4 or 2 to 3, and the small intestine, like pepsin. So so it just depends. And yeah, just like you can just take it as a definition that buffer it stabilizes the pH, and it stabilizes the enzyme in a way that it allows it to work in a good condition. And other buffer systems in our body, like we have a buffer system which is the bicarbonate blood, because of course without it our blood might be super acidic because of the carbon dioxide. We have carbon dioxide so much in our blood, the oxygenated blood. So we will have so much acidity in blood. So when our blood is super acidic, it will be like so wrong in the body. There's something wrong. So that's why blood itself have a buffer system. But this does not mean that like in our body there's no other buffer systems. There's so much buffer systems in our body in every way possible, and especially in the amino acids and the proteins. So like if you mean like it's on RBC, yes. Okay, perfect. So I don't know if you can see my screen. It's not shared yet, no. Okay. So stoichiometry. Okay, solids are characterized by having a definite shape and volume. Particles arrangement, particles are closely packed together. Okay, so particles are closely packed together. Particle movements, they are not super, like they have so no not so much distances between the particles in a solid. That's why you don't see a solid moving by itself. However, the liquid, it might move because they are much far from each other, the particles in liquid. So that's why you can see a motion inside the particles of liquid. However, the gas, it moves so much because there's a very huge distance between the particles. Liquids, of course, they don't have a definite shape. They take the shape of the container, but they have a definite volume. And particles, as we said, they are almost in contact, but they are not fully in contact. There's a distance between them, and they are free to flow. Gases, as we said, is super far from each others and they have a very huge distance and they are compressible. Plasma, it's not asked for the IMAT, but I'm gonna say it's a high energy state of matter characterized by electrically charged particles. It's found in stars, neon lights, and whatever. You don't have to focus about it, but it just you should know it have positives, like it have ions inside it. That's all. Like it does not focus on particles as normal, like solid, liquid, normal states, but does have positive and negative charge inside it. Kinetic energy of matter. Just 1 second. Okay. So the kinetic energy is the energy of an object possesses due to its motion. And as you all know, the formula of the kinetic energy is half mv squared. So it depends if half is a constant and the mass is a constant. So it depends on the velocity. The moment the velocity increases, the kinetic energy will increase. The moment the velocity decreases, the kinetic energy will decrease. And just describe how particles move in an object and the velocity of the particles, of course. So we're going to speak about the kinetic energy in the states. As a relation with the states, the solid has the lowest kinetic energy because, as we said, the particles are so close to each other, so they don't move, and when they don't move, there's no velocity exerted. Liquid, they have an intermediate because they might, like, particles might be next, like, collide to each other and might not collide, so it just depends. Gas, super high kinetic energy because they are freely going. And the plasma is extremely high because there is ions. Okay, so the states, you are asked about them. These are like one of the most important charts in chemistry. Okay, so matter can transition between different states. Liquid to solid, of course, we all know freezing. And gas to liquid condensation, solid to gas sublimation, gas to solid deposition, solid to liquid melting, or fusion. Gas to liquid, no, liquid to gas, evaporation, vaporization. Okay, so solid to liquid, um, yeah, yeah. That's what I wanted to say. I remember I spoke about it yesterday. So from solid to liquid, you are melting, so fusion happening, melting happening. So solid absorbs heat and turns into a liquid. Temperature at which it occurs is the melting point. So solid absorbs heat. When we said it absorbs heat, this means that the reactant is calories. The reactant is heat. So when it's absorbing heat, this means that this reaction, the melting reaction, is endothermic. Liquid to solid freezing, liquid loses heat. This means it produces heat, so freezing is exothermic. Liquid to gas, evaporation or boiling, absorbs heat, so it's also endothermic. Condensation loses its exothermic. These you should memorize them, the exo and the endo. Okay, sublimation. Some solids directly turn into gases. Dry ice is an example. Deposition. Gas directly turn into solids. Yeah, some solids. Yeah. So sublimation, you should take a note here. Without, let me try to, without passing the liquid state. The sublimation happens when the solid becomes a gas, but without passing the liquid state. We all know that the solid first becomes, like, let's say, ice, becomes water vapor. vapor. However, sublimation, it should not become water. When you see an example that the solid became liquid, this is not sublimation. Deposition is the complete opposite of sublimation. It's gas turning into solids without also passing the liquid state. So both of them. So for the exothermic and endothermic, you should memorize 2 by 2. These you're not asked about them. And solid, so melting is endo, evaporation is endo. So memorize me, this endo. And freezing and condensation is exo. Okay. So latent heat is, so the formula. Mm. So it's a Q equal to mA. The Q is the energy, which is like the calories or the total energy, how we can say. M is the mass, and L, which is the latent heat. So, yeah, let's go to the chart. So the latent heat is, okay, first, 1 second. So first we have to see like what is the latent heat, and then we go to the chart. Latent heat is the energy or the amount of energy or heat or calories absorbed or released by substance during a change in state. And of course, we should put in mind without a change of temperature. When the temperature is constant, we work on the latent heat. So it's the amount of energy absorbed or released. It depends on which reaction. If it was, let's say, melting, it's endothermic, so it's absorbed, you know? So it depends on the reaction. And let's now see the chart. So it's the amount of energy lost or gained. This is the latent heat as summary. Latent heat of fusion. Fusion means melting. Temperature remains constant as solid turns to liquid. On this point, it stayed constant. So the latent heat, the temperature here stayed constant as the solid turns to liquid, and same as vaporization. When it goes from a liquid state to a gas state, also the temperature remains constant. So when the temperature remains constant in the two phases, in the vaporization and in the melting, the latent heat is constant. We see here, no, I mean the temperature is constant, the latent heat is changing from a state to a state. So as we said, the latent heat is the amount of heat lost or gained by a process losing or gaining an amount of calories by having the temperature constant. Aqueous solution. The substance dissolved in water forms a solution. Water, universal solvent, known as universal solvent because it can dissolve many substances. And as we said, the reason is the polar nature and ability to form hydrogen bonds facilitate the dissolution process. So this we solved today morning, if you remember. And I think this is the most important note you can take from this slide. Polar and non-polar molecules, yeah. Finally, we came to the polar and non-polar. Okay. So the polar molecules have distinct positive and negative ends known as dipoles, or partially negative, partially positive ends. Cause arise from an unequal sharing of electrons in a bond. Non-polar have an even distribution of electric charge, cause electrons are shared more equally between atoms. So the polar, they have a positive and a negative end. Like, let's say, see, So let's say CO2, and here let's say CH4. So CO2, if you draw the Lewis symbol, carbon. So oxygen here is the partially negative, and here is partially negative. Carbon is partially positive because oxygen is higher electronegativity than carbon. So when we have two partially negative, and both of them are aligned on the same one, since carbon dioxide is a linear 3D shape. So this means that this negative will cross with this negative, and we will end up with the um, CO2, and this gives a nonpolar element. I mean molecule. So much students might say, okay, we have two oxygen in the CO2 molecule. So what does this mean? This, like, they will immediately say that this CO2 is a polar molecule. But when you draw the Lewis symbol of the CO2, you will end up with a nonpolar molecule. Because when you have on the two sides, symmetrical sides, two partially negative atoms together, especially here they are identical atoms, so you can cross them together and you will end up with just one charge, and this ends up with a nonpolar molecule. So then we take the CO2 and we put it with the nonpolar. So it does not really depend on, okay, it does depend on the electronegativity difference, but for a limit. There are some exceptions like CO2, and you should always know how to deal with it, because when you draw the CO2, when you draw the Lewis symbol of any element, maybe you will see the element symmetrical, you might see the element tetrahedral, you might see the element trigonal planar. So you have to see if the element have a symmetrical shape, it's immediately nonpolar. Like CH4, this have symmetrical shape, and other molecules. However, when you have the element which is asymmetrical, this is immediately a polar molecule. So how you can differentiate between them is just this way. And another way is, of course, to memorize the electronegativities. And you should know that fluorine have the highest electronegativity, oxygen after fluorine, you have bromine, you have iodine, all nonpolar atoms are super electronegative. Hydrogen is 2.1, I guess, in electronegativity. And the lowest electronegativity element, you also might be asked about it, and it is cesium, I guess. So the lowest electronegativity is this element. However, the highest electronegativity is fluorine. And if anyone have any question about polar and non-polar, please ask me. And we will speak more about them. Here we have so much slides about them. And we're gonna explain like one by one. So please, I want to make sure that you're understanding until now. Oh, okay, there's chat. What did you say? ME Indo, and the other one, I guess it was CF condensation. 1 second, let me make sure. Yeah, FC, it's exothermic. Means yeah, freezing and condensation. Freezing and condensation exothermic. Melting and evaporation are endothermic. This one here. Freezing, condensation, melting, and evaporation. Okay. Uh-huh. Good. So Determining factors of polarity, electronegativity. The difference in electronegativity between atoms in a bond, a large difference often leads to polarity. Molecular shape, even if bonds are polar, a symmetrical shape can make the entire molecule non-polar by balancing out the dipoles. Exactly. So here, as we have the CO2. So as we said, the CO2 ends up with two symmetrical um, sides. We have this side and this side. They're super symmetrical. So this ended up the CO2, which is super high electronegativity, it ended up making the CO2 nonpolar. So of course, you should take as a priority the electronegativity to be able to differentiate between the polar and the nonpolar molecule. However, if you reached a point, let's say you came to a point, okay, it is like 0.4 or it is 1.9, and you didn't know what to do in this, or 1.7, let's say. So you reach a point which is the limit. Here you start looking at the shape, and of course you should take into consideration all of them. Importance of polarity influences solubility, melting and boiling points, and interactions with other molecules. So of course polarity, of course it influences solubility because high polar, I mean like polar solvent, allow more polar solutes to be dissolving. Non-polar solvent is easily dissolved, non-polar solute is easily dissolved in non-polar solvent. Melting and boiling points and interactions with other molecules. Um, I want to speak something about the boiling point. So let's take into consideration NaCl. One second. Okay. So let's take into consideration NaCl. Let's put it in water. Want to dissolve it. It dissolves into Na plus and Cl minus. So how many molecules does it dissolve? It dissolves into two molecules. Let's say KBr, K plus Br minus, and we want to dissolve it in water. And this between them is ionic bond, and this also is ionic bond. Okay. So let's dissolve KBr, K plus and Br minus. So also it ends up with two molecules or two ions, and here it ends up with two ions. So both of them ended up in the same amount of molecules. This means that these two solutions have the same boiling point. So the note I want you to take here is that, one second, no way. So the note here is that the boiling point only depends on the number of molecules. This one. I don't know my handwriting. It's okay. Try to take notes when I'm speaking. So, as you said, so you might, I saw a question in the Imat or in the talk, I'm not remembering where. So it speaks about, it gives you like, let's say two things to, let's say two solutions, and tells you, oh, which one have the same boiling point, or so you here have to choose. What do? You just go and divide them. How we say, you just do the dissociation reaction, and ACl gives Na plus plus Cl minus, KBr gives K plus plus Br minus. Compare the number of molecules, and here you will find out the same boiling point, or melting is the same. Electronegativity measures an atom's ability to attract and hold on to electrons. The greater the electronegativity, the stronger an atom can pull electrons toward itself. Bond polarity, the difference in electronegativity between two atoms can indicate whether a bond is polar or nonpolar. Large differences often result in polar bonds. Small differences typically lead to nonpolar bonds. And super large differences lead to ionic bonds. HCl, we can see that H hydrogen have partially positive. It's a partially positive ion. Why? Look, I tell you something about hydrogen. Hydrogen is an electronegative atom. It's not like it's not. It is 2.1. So it is electronegative. However, hydrogen with metals, when you put hydrogen with metals, let's say with magnesium, with sodium, with calcium. So when you put H with Cu, copper, whatever, it will be so high electronegativity. And then here, hydrogen will be holding the partially negative. However, when you put hydrogen with any non-metal, chlorine, fluorine, carbon, nitrogen, phosphor, when you put hydrogen with one of the non-polar substances, it will end up with a partially positive charge. So here it ended up with a partially positive just because Cl is more electronegative than it. It ends up um, in a polar shape. I mean, in a polar molecule. H2O, it's also polar because we have oxygen, which is super partially negative, and we have two hydrogens. And I want to tell you something that does not depend on the amount of molecules we have to end up with let's say we have two oxygen. This does not mean having two oxygen, oh, it's super polar, no, because we have two electronegatives. It's a no, because it does not depend on the number of molecules, it just depends on the molecule itself. Here we have two hydrogens. This does not mean having two positive can delete a negative, no. So also polar, NH3, also it's a polar because nitrogen is super electronegative. Now, what you should memorize about nonpolar, any carbon and hydrogen, it's always nonpolar. Any molecule, which is any like element times 2, it's nonpolar. C2, B2, N2, H2, whatever. Why? Because let's say we have, or also 2, because let's say we have 2, we just delete them. And why is CCl4 is nonpolar? Although Cl is very electronegative, and carbon is also electronegative, but why it ends up in nonpolarity molecule is because we have symmetry. When we have symmetry, it ends up in a nonpolar molecule. So we have to take into consideration everything. Okay. Chemical equations, 2H2 plus O2 gives 2H2O. Combustion, yes. Okay, I'm gonna teach you a trick to solve combustion reaction questions in the Imat. Just give me 1 second. So hot here. Okay. So you might see so much questions, and we will solve them tomorrow. And please, guys, when I'm gonna put assignment on the website, please solve them. I want to see your base. So please try to do all the assignments. I'm gonna check them before tomorrow, and tomorrow morning we're gonna check them together. This will allow you to try yourself before us solving together. Since no one interacts with me, so I need to do the assignment thingy. Before I didn't want, but now after this, no way. So let me just make sure there's no chats. Yeah. Welcome, Saeed. Only 4? No way. Okay. Should I go ahead, or you got tired, you need a break? Tell me so I see what to do. Go ahead. Okay. Okay, let's see. So of course, you guys know about chemical equations. You all have the base. I'm not gonna explain these things because super basic, like the reactants and the products. Of course, you know about them. You know that these are coefficients, these are subscripts and whatever. Combustion reaction is you always have to combust a hydrocarbon with oxygen, giving carbon dioxide, heat, plus water. Okay. Now, you see so much in the IMAT. They try to get you equations, combustion reaction equations in order to balance, and you need to take time to balance them. And not just by balancing, like they ask in very different ways, in a way that they want you to not know how to balance the equation of combustion reaction. They try to trick you in all ways. So I found a formula which you can just memorize it and balance it super easily in any equation the moment you have a hydrocarbon means only carbon and hydrogen without oxygen. If you have glucose, CHO, so no, this equation, this formula does not work on glucose. But most likely in the IMAT is always asked about hydrocarbon combustion, like methane, like ethane, whatever. So I'm gonna give you now the formula. CHY, write this formula down, plus okay, x plus y على 4 O2 gives x CO2 plus y over 2 H2O plus heat. X is the carbon subscript and Y is the hydrogen subscript. So let's give an example. Let's say we have anything, any alkane, let's say CnH2n plus 2. Let's say we have methane, let's say CH4. So carbon have 1, hydrogen have 4, so let's say 1 plus 4 over 4, 2 gives CO2 plus 2H2O plus heat. 1 plus 4 over 4 is 2O2. So you see how it's easily balanced. Now they might get you like hexane and nonane and decane and big numbers and whatever. So all you have to do is memorize this formula and just know how to work with the combustion. Super easy. So I think you screenshot it or you can get it from the recording or write it. Synthesis reaction means you have two reactants and then you end up with a product having both of the reactants. Decomposition reaction is dissolving, let's say, any solute in water, or let's say dissociating a big molecule. So AB gives A plus B, NaCl, Na plus Cl. Single displacement reaction means A plus BC gives AC plus B. The first one and the last one together, and the one which is after the plus gets to the side. Single displacement reaction. Double displacement reaction is the first one and the last one together, the second and this way, memorize it like this. This double displacement. Acid-base reaction. Okay. Of course, acid plus base gives salt and water, and this reaction is called neutralization reaction. Because when you add an acid and the base, you try to neutralize the pH. So acid plus base gives acid, salt, and water. Reaction type, combustion, formation of carbohydrate, carbon dioxide, water, and heat. Combination reaction. Combination is the addition of two or more simple reactants to form a complex product. Decomposition reaction is when complex reactants are broken down into simpler products. Double displacement is this. Is when two elements from one reactant switch with two elements from the other to form a new reactant. Single displacement is when an element from one reactant switches with an element in the other to form two new reactants. Always remember that the one after the plus should go out by itself. Acid-base is a neutralization reactant forming salts and water. Derived from Greek words, done. That's not important. Okay, principal matter is neither created. Yeah. So balancing. I'm gonna teach you how to balance now. Okay, no one cares about the importance. All of this about balancing. Okay, let me teach you how to balance. Let me go to the white keyboard. Wait, it's not working. Okay. Perfect. So I'm gonna share the white keyboard. I mean the whiteboard. Okay. Is it shared? Can see? Perfect. Perfect. Thank you. Thank you. Thank you. Okay. So guys, number one, we spoke about okay. So guys, we spoke about first the okay. The combustion reaction balancing. So memorize for the combustion reaction of hydrocarbons only, CXHY plus X plus Y over 4 O2 gives XPO2 plus Y over 2 H2O. This is only for the combustion. Just take this, take the combustion on the side, memorize the combustion. And now we will go for all other reactions with a very easy formula. So the combustion, this is the combustion. All other you should do something. A plus B gives C plus D. So what do you do? Any reaction you have in the Imat, you just put the reactants and put the products, put before each one small letters A, B, C, D. And then put here not CD, I'm sorry for this. 1 second. Okay, perfect. Now it's better. So A plus B gives AB. So A, B, C in this way, yeah. So guys, what do you do? What's going on? Okay. Okay, now. So A plus B gives C AB. So first, number one thing you have to do is to put the coefficients with letters. And then you have to put here the elements. We have AB, and here we have also AB. So after this, what do? We put, how many A's do we have for the A? We have an A. B, we have an B. A here have a C, and B here have a C. And we put between them an equal. So A equals to C equals to B. So now our equation is balanced. Now I gave you a simple reaction, which is the easiest one, the addition. But when it goes to like hard reactions, it becomes so hard. So I'm gonna now get an example from the past papers. We're gonna solve it now before we continue anything about that. So take a screenshot and let me just check where is the example. And for the video of the physics and math, I didn't do it yet. I was really busy. I'm gonna do it today after the course. Okay, perfect. Who's on chat? Okay, perfect. So should we get from the island? Okay. So I'm gonna change the whiteboard to have a better space to solve it. Okay. So let's say we have C4 O2 gives CO2 plus H2O. So here what do? We just put A, B, C, D. CHO, CHO, and you have to try to practice so it will be so fast. And then here you put A, here you put C. Let's put it in a better place. For A, because here it has a 4. Hydrogen here have a 2D. Oxygen here have a A plus 2B. 2B and A. And oxygen here have a D. You put an equal between them. A equals to C to A. Here we have a system of math. 4A equals to D. Sorry. Okay. Equals to 2D. And A plus 2B equals to D. So what do we do here? Number one thing we have to do after we reach this point is to put one of the letters equals to 1. So here let's always try to take the first one equals to 1. So let's take A equals to 1. Okay? You have to always take one element equals to 1. One of the, the small letters that you added. So A equals to C equals to 1. For A equals to 2D, this means that 2D equals to 4. This means D equals to 2. So now we have A equals to C equals to 1, D equals to 2. And A is 1, so 1 plus 2B equals to 2. 2B equals to 2 minus 1 equals to 1. B equals to 1 over 2. So now we just put 1 over 2 here. We put a 1 here. We put a 1 here. And we put a 2 here. And we cannot have a fraction in the balancing of the equation. So what do? We just multiply all the equation by 2. So now we have a 2 here. It's a huge mess. Do this. We have a 2 here. Here 1 over 2 times 2 equals to 1. So we have to delete. And then we delete this. There'll be a 2 here and a 4 there. And this is the balanced equation. So when you try to practice like at least 3 equations on a hard basis, I think you'll be able so easily to solve them so fast, like in this way. And any hard equation, خلاص, this is your like the way to solve any hard, any big one, any whatever. You just put the elements here, but in a very fast way because the Imat should be so fast. So try to do this super fast. Put one of the subscripts equal to 1, and then try to solve it mathematically, and then you will end up in a very good, easily balanced equation. Instead of thinking, oh, we have 1c here, and we should have 2c, and in this way, it's much easier, much mathematical. Okay. So where were we? Now let me try to. Okay, anyone have a question? Can you repeat first step again? Okay, perfect. One IMAT question with this method, please. So I tried to find the IMAT question. I cannot find any, so I have to really search in the test spectators if I can find anything. So we're gonna take a break after I repeat the first step for Ifra, and then we will solve one on the IMAT, okay? So because we're gonna take a 5 minutes break, and this 5 minutes I'm gonna be searching for the equation. So for Ifra, I'm gonna explain the first step. If you want, I can explain it all again, no problem. So, okay, look here. Let's say you have then A plus B equals to AB. So you put here A, B, C. And then you put A, B, here A, B. And here you put A, here you put B. Why? Because here the A have an A, here the B have a B. Here the A have a C and the B have a C. You put them equal and you take one of these four, or I mean of these three, of A or B or C, the ones that you suggested, the ones that you added, you put 1 equals to 1. The moment you took one of these three equals to 1, you ended up with what? You ended up with the system, with the mathematical system. When you have the mathematical system, you just try to solve it and you will end up with a very good equation. And we're gonna solve now an example in the Imat, so you're gonna understand it much easier. Don't worry about it. So, okay. So let's take a break 5 minutes. I'm gonna search for the question and then we will solve it and continue the chemistry. You can go drink water. Yeah. Sayed, thank you so much. Really, thank you. And we're gonna solve these two. And I'm sorry I didn't solve today morning the question that you asked about yesterday. I'm gonna also solve. So this three questions, I will solve them, then I will continue the course. Okay. Okay, give me like 5 minutes. Take a break, guys, and then I'm gonna come back and we will continue. So give me some time. Okay, guys, you still here? Perfect. Okay, so I came back. We're gonna solve first the ones that Said gave us. So let me just write the equation on my paper. So the first equation given is First one, okay. 4 KMnO4 plus AH2SO4 plus 5C2H5OH CH2. Okay, يلا. Let's do this. I'm gonna share the whiteboard. Perfect. So, yeah, what was the question? I forgot. Let me just go make sure what's the question. Okay, the question is, what value does C need to be so that the following equation can be bent? So they're asking us about C, which is the one of H2. Perfect. Okay, let's do this. And for 4. Please, guys, make sure I'm not writing nothing wrong. Because it's so big equation. Okay. So first thing, we have to write the elements on both sides here. So K, M, N, O, H, S, C. These are the elements. And we write the same here. K, M, N, O, H, S, C. Okay, here we have only 4. Mn we have also 4. Oxygen we have 16 plus 4A plus 5. And S we have an A, C we have a 10. On the other side we have, no, hydrogen we have more. We didn't write the hydrogen, yeah. So 2A plus 25, 26 must be here. Can take this edge. So 6 times 5 equals to 30. K here is K here, where's the K? 2B. MN is a 4, but of course it should be faster, but my hand is not used so much to write on a tablet. MN is 4. Oxygen is 16 plus 4B plus 2 plus 10 plus C. Hydrogen is 315. I'm not understanding, why are they doing this? Why it's so hard to put all the hydrogens together? Here is 5, 6. Here, let's put here 4. Take this off. Okay, so hydrogen is 20, just to see. S is 4 plus B, and C is 5. It's a 10. Okay, perfect. Now we put an equal between them. And yeah, so we have 4. Let's write it here. 4 equals to 2b. 4 equals to 4, so mn is already balanced. 16 plus 4a plus 5 equals to 16 plus 4b plus 10 plus c. 2a plus 30 equals to 20 plus 2c. A plus equals to 4 plus b, and 10, of course, equals to 10, so we don't care about it. So we use these equations in order to solve c. If 4 equals to 2b, this means that b equals to 2. Okay, so we have already b here, it's 2. 16 plus 4a plus 5, so 16 plus 4a plus 5 equals 16 plus 4b plus 10 plus c. So 16, 21 plus 4a equals 16, 26 plus 4b plus c. 2a plus 30 equals to 20 plus 2c. 2a equals to 20 minus 30 minus 10. 2c minus 10. And a equals to 4 plus b. B we already have it, which is 2. So 4 plus 2 is 6. So a equals to 6. So now we have the a. So 21, we do substitution, plus 24 equals to 26 plus 4b. 26 plus 4, b plus c. B we have it, which is 6. So 6 times 4 is 24. So then we do 40, it's so big. So 46, no, 45. 26 plus 24, or 50. Ah, yeah, it ended up a minus. One moment. Let me do something. 2a equal to c minus 10. 2a means 2 times 6, 12. Is the answer 11? Let me make sure. Say it was the answer 11. Was it B, the answer? Yeah, so it ends up 11. How C is 11? Because, so I did a mistake, and I'm gonna just tell you what was the mistake. Is I was going to solve the harder equation, which is this. Let me try choose another color because we have a huge mess here. So, okay, whatever. I did a huge mess. I used this one here, this equation. But we have to use the easier equation, which is this. 2a equals to 2c minus 10. So 12 equals to 2c minus 10. 2c equals to 20. 2c equals to 11. So I guess in this huge problem, just try to find the equation which is simpler and try to find c. But I did the problem and I started with the harder. That's all. But try to solve it faster. I'm not used to solving on tablet, and try to be like faster in on mind. That's all. So it is effective, but you just really have to put in hand, and you should remember you're not writing on a computer, you're writing on a paper, which is much easier. And I'm not joking, it does not take time, just took time now because of problems. So try this. If you don't feel comfortable with this, you can use the normal method, which is you see here. I'm gonna tell you. So you see how much K we have, how many K we have here. We go see we should have the same balance in the second. How many oxygen we have here, we try to balance it in this way. But I think this is the most effective method in very hard things the easiest method is to solve it mathematically. Oh, okay. Is it clear or should I repeat? Perfect. Okay, let's do this. Let's do the second one. Yeah, second one is much easier, I guess. Much easier. First one was a disaster. So P2I4 plus BP4 plus CH2O gives PH4I plus H3PO4E. Okay, let's write it. Yeah, faster, let's be fast. Okay, guys, so focus on this. I guess this is much simpler, so okay, can anyone just tell me what was the question? Okay, let me just make sure. Yeah, value of B. Okay, perfect. So the value of B here, B, let it be I H O P I H O. Here we have a 2A, here we have 4A, here we have 2C, here we have a C, here we have plus 4B. Here we have 4, no, is this a P? P, yeah, it's P. So here we have a 1 plus E. Here we have 4, no, I has a 1. H has a 3E plus 4. Oxygen have a 4E. Equal. 2A plus 4B equals 1 plus E. 4A equals to 1 means A equals to 1 over 4. 2C equals to 3E plus 4. C equals to 4E. We should remember, okay, let's try to just A equals to 1 over 4 means 1 over 2. 1 over 2 plus 4B equals to 1 plus E. 2C equals 3E plus 4. And C equals to 4E. So here we have, instead of just putting a 1, we have two equations. PH. Oh, 1 second. He's saying something. Make sure what did he say. Value of B. There is a D before PH for. Oh, okay, okay. Thank you, Sayed. Thank you. PH for I. Ah, okay. Okay, thank you, thank you. There is a D. Product site. Okay. So here we have a D. Okay, now it's better. Okay, let's do this. Everything changed. So we have a D plus E. We have a D. We have a 3E plus 4D. Oxygen, we have a 4E. And yeah, that's all, I guess. You know, everything changed. It was here a 2A, right? 2A equals to D plus E. A equals to D. So A equals to D, guys. I mean, 4A equals to D. 2c equals to 3e plus 4d, c equals to 4e. Now here, in this moment, we have to take one of them equals to 1, so here we take a equals to 1. Why? Because we cannot find any system, we cannot find nothing. So 2 times 1 is 2, 2 equals to d plus e. So 2 equals d plus e. 4a equals to d means 4 equals to d, so d is equal to 4. 2c equals 3e plus 4d, so 2c equals 3e plus 16. C equals to 4e, so c equals to 4e. Okay, where's the b? b4. Okay, I forgot the b. 2a plus 4b. 2 plus 4b equals to d plus e. Okay, now it's perfect. So d is equals to 4, so 2 plus 4b equals to 4 plus e. Okay, now let's take these off. And c equals to 4e. If c equals to 4e, so here we can replace this c with 4e, so 2 times 4 is 8, 8e equals to 3e plus 16, so 8e minus 3e, 5e, okay, equals 16, e equals to 16 over 5. And we found the e, so 4 plus 16 over 5, 2 plus 4b equals to 4 plus 16 over 5. And then we find the b from this equation, so we have 2 plus 4b, 4 plus 16 over 5, times 5, 2 plus 4b, 20 plus 16, 36. And then cross multiplication. Guys, the place is so messy. I cannot work in this place. Look, for the balancing, let's do this because it's taking so much time. And I already showed you how to balance. So what I'm gonna do is I'm gonna explain it on a paper, not just this. All the balancing questions. Yeah, I think so. So it's super messy and it's super. It needs to be on a paper. I cannot explain it this way. So I'm gonna explain all the balancing equations. And some like give me just today and tomorrow. I'm gonna send the videos on the group, and you watch them and you see the way of doing them. So I think it's much easier on to look at a paper and see how it's solved than to see on a keyboard. So leave the balancing for me. I'm gonna do it. I'm gonna send it. It's better than using our time of the class to unbalancing. I think we have to do course. We have to study things which is more important, and this things is more about practice. You have to practice your hands on the formula that I gave you. And of course, I'm gonna give you like some examples of balancing on the about the Imat past papers on the group. So don't you worry about it. Okay. So just Ali asked me something about his about what was the mass of magnesium oxide. Okay, let me just solve this so fast before we continue, because I don't want to make no one sad. Yeah, bravo, Sayed, exactly. Yeah, bravo. Okay, so the moment he told you excess oxygen, so here you should look on the limiting reactant. Who is the limiting reactant? Is the reactant which is not an excess. It's the second reactant. So when he told you that we put magnesium oxide, we have to write the equation of creating the magnesium oxide. So you just write 2 Mg plus O2 gives 2 MgO. You put, according to stoichiometric proportion, number of moles of Mg over the coefficient, which is 2, equals the number of moles of MgO over 2. Why did we put the coefficients? We put them down, and number of moles. Why did I choose the number of moles of Mg equals to the product and not the number of moles of O2 equals to the product? Because in the question he told us that oxygen is in excess. So when we have a reactant which is in excess, we cannot take it into consideration in the stoichiometric proportions. So we always, oh, I'm sorry. So we always taking into consideration, consider the limiting. And then here we can cross the 2 by 2, and then number of Mg equals, so means N equals to M over N, mass of magnesium over molar mass of magnesium equals to mass of magnesium oxide over molar mass of magnesium oxide. So 75 over 24 equals to mass of magnesium oxide, which is the question, over 40. And then you just do the cross multiplication, you end up with a mass equals to 125 grams. If you have any question, just tell me. Is it clear, Ali? Perfect. Okay, now we have to continue the slides. I'm ending the meeting for no reason. Okay, let's go. I'm gonna share my screen. As I said, for the balancing, don't you worry, I'm gonna send the video. Don't worry about it. Perfect. So what did we speak about? Yeah, here we were speaking about the balancing. Let's go far from this. Okay, mole. Perfect. So the mole, of course, is the amount of the quantity of particles and substances, and it is 6.022. It's the Avogadro's number times 10 power 23 entities. So the formulas that you must know for the Imat is just number of moles equals mass in grams over the molar mass in grams per mole. Another one you should know, number of moles equals to number of molecules over the Avogadro's number, which is equal to 6.02 times 10 power 23. These are the only two formulas, the basic formulas that you should know for the Imat. Stoichiometric calculations, as we said, according to stoichiometric proportions, you're going to put the number of moles over the coefficients and taking into consideration only the limiting reactant. Molarity is the moles of solute over liters of solution. So it's the number of moles. Molarity is the number of moles over volume of the solution, or number of moles of solute in 1 liter of solution. Number of moles of solute in 1 liter of solution, or according to the volume in liters. Now, the molarity is almost the same equation of the concentration. If I think we all know the formula, which is C equals to N over V. So the concentration is almost the same of the molarity. So you can also memorize this thing. And the definition of the molarity is the number of moles of solute over 1 liter of solution. Finding the molar mass, you just have to memorize the molar masses of the elements in the periodic table, and then you'll be able to find the whole molar mass of a compound. Let's say you have H2O, you have hydrogen, which is 1, and oxygen, which is 16. So 2 plus 16 equals to 18. Why 2? Because we have 2 hydrogen, 2 times 1. Yeah. Density is mass over volume. And of course, you can do the triangle method, like the crisscross multiplication gives m equals to density times volume and gives volume equals to mass over density. So you can use in any formula you can. In physics, chemistry, or anything. Okay. Moles, molality. Yeah, here the same. You can do the triangle method. I think you all know this thing. Empirical formula. So empirical formula is called also the minimal formula. Empirical formula is the same as the molecular formula, but there is only one difference, which is that empirical formula equals x times molecular formula. No, I think molecular formula equals to x times empirical formula. Because the empirical formula is the minimal formula, means if we have a CH, if you multiply this molecular formula by 2, you will end up by C2H2, which is the same. If you multiply by 3, it will end up by C6H6, but you're still CH. So the CH itself is the empirical formula. However, this is the molecular formula. So the molecular formula is times the empirical formula. Anyone have any question? Solution. The solution of what? It was not 125? You sure about it? Yeah, the method. I was teaching you don't look at the methods in the Ultimate Imat book because it's super complex methods. The method I give you here is much easier, just put them over each other, that's all. And stoichiometry is one of the most basic things you should know for the IMAT. So try to practice more questions like this. Okay. 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 So we spoke about the empirical formula and the molecular formula. Now we should know how to calculate the empirical formula, how to calculate the molecular formula. Let's go ahead. Okay, it's not charging. Perfect. So to determine the empirical formula of a molecule, you have to identify the elements, determine which elements are present in the molecule, determine the ratio, simplify the ratio to the simplest number, and then you will end up with the empirical formula. To determine the molecular formula from the empirical formula, start with the empirical formula, and then find the molecular mass, and then divide and calculate. You have to divide the molecular mass by the molar mass of the empirical formula. Multiply the subscripts in the empirical formula by the factor obtained in step 3 to get the molecular formula. So you get the molecular formula by multiplying the factor. Here, if you see that here we end up, no. Okay, this is the last slide. So as we said, that way to find the molecular formula from the empirical formula, you have to start with the factor. You have to try to find out the factor, and then you have to find the molecular formula. Um, so there are so many formulas that you can do to obtain it, but I guess using the method of um, dividing by the smallest number, the smallest ratio is the easier. Let's say we have let's say we have a ratio of 3.2. Ratio means number of moles over the coefficient. Let's say we have A plus B gives AB, A, B, C. So the number of moles, let's say the A, so N of A over A. This is the ratio. So the ratio equals to 3.2, let's say, and the other ratio of B, R1 and R2 equals to 3.3. So 3.2 is the smaller. So what do we do to obtain the formula? We divide it by the smallest number, which is 3.2, and here divided by 3.2, and then here we end up with a 1, and here we end up with a what? With a 1, since they are so close to each other. So this means that both of them are limiting, to be honest. So then ending up, and no, this means that the equation is in equilibrium. So ending up, we will have AB. The molecular formula will be AB. Okay. I also want to explain something before we change the topic. Okay, look here, guys. If we have, let's say, any equation, and how to determine the limiting. So the limiting reactant is so easily to be determined. If we have, as we said, A plus B gives AB. So we have to put the number of moles of A over the coefficient of A, number of moles of B over the coefficient of B, ratio 1, ratio 2. The one that gives the least number is the limiting reactant. The ratio that gives the highest number is the excess reactant. In the stoichiometric proportions, when we say according to stoichiometric proportions, we take the number of moles of the limiting of R1. So number of moles of A over A equals the number of moles of the product, which is AB over C. So we should always take into consideration only the limiting. To know which reactant is the limiting, we should do the ratio. The ratio is number of moles over the coefficient. Okay, so I think why am I going so fast in the slides? Because we just have 23 days in this course. Like by the end of August, on 31 August, we will finish. I want to try to go through all the notes I have in 2 years. I want to try to go through everything I have. So because the IMAT is a very detailed course, so I should always try to go to the details more than the base, you know? And I think all of you have already this thing, this basis. So that's why you will see me speaking so fast. And I think you are going through my pace, because I think if you didn't, if you don't know these things, you would not accept me speaking this fast. So I guess me speaking fast is okay because you all have the space, and when I speak slow, is I'm speaking on a thing which is a detail which is more important that you might not know. So so that's why I'm going fast. It's not that I want to go fast. Okay. So any questions? Said. Sample of an oxide of iron contains 1.68 grams of iron, 0.64 grams of oxygen. Okay. And what's the formula of this oxide? Perfect. Perfect. Said. So we have Here, let me just write the grams. E and 0.64 grams oxygen. Okay, so the whiteboard. So Fe, okay. So number of moles of Fe equals to mass over molar mass equals to 1.68 over 56. Number of moles of oxygen equals to mass over molar mass, which is what was it? 16, 0.64 over 16. Okay, 1.60 divided by 56. This, of course, you should not use the calculator while solving to be fast now. And 0.64 divided by 16, 0.04. So, of course, and of course, the ratio here between them is a 1. So, n over 1, n over 1, 0.03 over 1, 0.04 over 1. So, the limiting reactant is Fe. Here's the limiting. Okay. So, now they said that what is the formula? So what do? We just divide by the smallest number. So we end up dividing 0.03 by 0.03, 0.04 by 0.04, and then we'll give a 1 and by 0.03, I'm sorry. And it will give a 1 here and a 1 here. It will be 1.3, so rounding it will end up 1.0. So I guess it's FeO. Just make me sure that it's correct. Not correct. So what is the answer given? Okay, 1 second. Of course, take your time. Fe3O4. Okay. Just make sure what's the wrong thing. I guess we just did a mistake. Something, we still have the board. Yeah. Okay. Just delete. Yeah. So I guess the only problem was that we have to calculate the mole ratio of iron to oxygen. So we should calculate the mole ratio, you know. So what should we do? Is to divide 0.03 over to 0.04. Because when we divide, so we have to, the only trick here, I told you, like, Imat is so tricky, so we have to always find the trick. So we have to find the mole ratio of iron to oxygen. What is the mole ratio of iron to oxygen? It's moles of iron means number of moles of Fe over number of moles of oxygen means 0.03 over 0.04 equals to 0.7525. So if you see here, because when we want to find the molecular formula, the only mistake I did is that I did a confusion between the molecular formula and the empirical formula. In the empirical formula, you have to divide with the smallest number. However, the molecular formula or the formula, when they ask for formula without the minimal formula, you should not divide by the smaller number, because the empirical formula, its definition is being minimum, means you have to divide by the smaller, by the minimum. However, the molecular formula you should take according to what you have. So you should get the mole ratio of the element to the other element. So here we take the mole ratio of the smaller element of the smaller number of moles over the bigger number of moles. So of Fe over oxygen, and we will end up with 0.7525. So now we simplified the mole ratio to obtain the formula. How? The mole ratio will end up 0.75 means equals to 3 over 4. So when you end up with 3 over 4, means the ratio between these two is 3, 4, means Fe3 over 4. So when you want to find the molecular formula, we don't divide with the smaller number. When we want to find the molecular formula, we try to find the mole ratio between the atoms. The moment we found the mole ratio between the elements, we just put the ratio for each one. 3 to Fe, 4 to O. 4 to O. We divide, we find the number of moles, and we divide them together. That's all you have to do for the molecular formula. For the molecular formula, you have to divide the number of moles of the atoms by each other to end up with a ratio. And then this ratio is the same molecular formula. How did you get a 3 over 4 from 0. Okay, so I'm going to explain it in a mathematical way. 0.03 over 0.04 equals to 3 times 10 power minus 2 over 4 times 10 power minus 2. Take off the 10 power minus 2, it will end up at 3 over 4. So is everything clear, guys? Do anyone have a confusion, didn't understand something? Perfect. Perfect. Okay. Guys, do you still have mind to solve something? Like, if I now added like 15 minutes to solve some math or physics, would you like have mind, or you want us to end the class? Because it's already 7, but like me myself, I would like to give like a 15 minutes to 30 minutes math and physics. So just tell me if you are okay with this or you don't want. I'm here to listen. Yeah, stop sharing. So guys, you want math and physics or no? Like in 15 minutes, we solve some math and physics from any session. Okay, perfect. Thank you, Saeed. Okay. Saeed is the most interacting man on earth. You're welcome. So let's try to solve the metaphysics of, because I think solving it together, I think it's really much better than just sending a video. I will do the video, but still it's better. So let's go for 2020. So 2020, let me just share the screen. Okay. Okay. Perfect. Yeah. I'm gonna share the screen now. No, I'm sharing. Okay. So let's try to solve 2020 physics and math as much as we can. And then we're gonna see it. So not chemistry. Yeah. So let's start here. 2 over 2 plus radical 3, which one of them? So here we have to rationalize. Rationalize means we have to multiply by the negative or by the opposite number. And of course, to take off the radical from the denominator, we must rationalize. This is the main reason of rationalizing, is taking off or eliminating the radical from the denominator. So we multiply by 2 minus radical 3. Of course, the numerator and the denominator, because if we eliminate them, both of them, it will be equals to 1. So this means you multiply by 1. So then 2 plus radical 3, 2 minus radical 3, it's okay, I forgot the name, but this ends up with a minus b into a plus b, ends up with a square minus b square. So 2 square minus radical 3 square ends up with a 4 minus 9. So 2 over 2 into 2 minus radical 3, because we should not forget this, over minus 5. So let's multiply the numerator. Yeah. 4 minus 2 radical 3 over minus 5. So this means minus. So let's divide like this. Can do that. So minus 4 over 5 plus 2 radical 3 over 5. Let me make sure if it's... No, it must... Okay, what did I just do? Let me delete. 1 second, guys. 1 second. Why it ended up with a 5? I'm not understanding. Let me make sure of something. Must not end up with a 5. let's start. Let's try again. Okay, let's do this. Okay, look, guys. We should, of course, multiply by 2 minus radical 3. This I'm sure about it. So 2 into 2 minus radical 3 over 4 minus 3. Oh, 4 minus 3. Yeah, we did this wrong. So 2 into 2 minus radical 3 over 1 equals 4 minus 2 radical 3 equals b. Okay, so I don't know from where 5 came, but yeah. So it ends up with the b. 54. So what are the coordinates of the turning point and of the graph of the quadratic equation? Y equal to 2x squared plus 5x minus 2. The moment you see turning point, the moment you see the word turning point, take into consideration x. Okay? And memorize turning point equals, means x equals minus b over, what happened? Minus b over 2a. So the moment we see turning point, the formula is x equals to minus b over 2a. So we just get the x. B means 5, a is 2, this a, b, c, you know? So minus 5 over 2 times 2, which is 4 minus 5 over 4. So the x is minus 5 over 4. So it's either a, either b. These, we can eliminate them. Now we already have the x. We just replace in the equation. So y equals to 2 times minus 5 over 4 plus 5 times minus 5 over 4 minus 2. So we end up with y equals times 2, so minus 5 over 2 and plus 5 times minus 5, so minus 25 over 4 minus 2. And of course, over 1, and we multiply by 4, we multiply by 4, we multiply by 2, we multiply by 2, ending up y equals to minus 41 over 8, and we can choose B. So until now, did everyone understand, or should I repeat anything from these? If anyone have question about the turning point, just tell me. Oh, there's a good chat. 3, not 9. Exactly, yeah, I did this wrong. 20 is everything right. I'm confused. Okay. Perfect. So, okay, now physics. Rocket. A rocket is launched vertically from the surface of the Earth. As it leaves the launch pad, the total mass of the rocket and its contents is m. The gravitational field strength of the Earth's surface is g. The rocket motor provides an upward vertical thrust T to the rocket. So, of course, we all know that gravitational force is always going downwards because it's gravity, and of course, gravity force will push us downwards. The thrust, or this rocket, is going up. So this ends that the force of gravity, instead of going down, is going up. So here we have a negative. We should put in mind, since we saw the direction is positive when we go downward, and is negative when we go upward. So we should put in mind the negative one side. Of course, we should see the second law of Newton. Sum of forces equals to ma. So he wants the acceleration. So A equals the sum of forces over the mass. And the forces here are the thrust and the weight. So acceleration equal to the thrust over, sum of forces is both of them. So thrust minus the weight, which is mg. Y minus, the thrust is going upward and the motion is going, and the thrust, the force of thrust is going upward with the motion of the thrust. However, the motion of gravity is going down and mg is going the complete uh, the rocket is going the complete opposite direction, so it's minus mg. So we use the negative here. So T minus mg over T minus mg over m. Now we just divide and we enter the m between under both يعني. A equals to T over m minus mg over m. Here we have a times, so we can eliminate the m, equals T over m minus g. So it's A. Okay. Math. Now we have math. What's the value of x? Let's see. Let me just make sure there's no questions, because in math and physics, I think so much questions can be asked. Yeah, there's chat. Trust will be positive. Humera, can you please explain this again? The physics part, right? Perfect. Okay, I will do it. Okay. So Humera, look at the rocket. The rocket is going upward. Okay, the rocket want to fly, going upward. The gravity is going always downward. So when the gravity goes downwards, what happens? Like the rocket is going upwards and the gravity is going downwards. So we have here an opposition of direction, you know? So who is the force that contains the gravity itself? Weight is the force that contains the gravity itself. So the since the weight have the gravity, so the direction of the weight, or the sign of the weight, must be minus mg. Because if you see that the rocket is upward, however, the gravity, the earthly gravity is always downward, always take us downward. So we have a difference in that direction. So by this, we have a minus mg. According to the second law of Newton, we know that Newton has three laws. And the second law of Newton, the sum of forces equals to mass times the acceleration. So the x, he is asking us here in the question about the acceleration. So sum of forces equals to the mass times acceleration. If you do this crisscross method, the triangle method, whatever, you will end up acceleration equals the sum of forces over the mass. The two forces here that we have are the thrust and the weight. If you see that the vector of the thrust force is going upwards with the rocket, with the direction of the rocket. So it will be plus T. And the gravity is going downwards, and mg is going, and the gravity is going downwards, and the weight is going downwards, but the rocket itself is going upwards. So there is here an opposition. So we put a minus mg. So T minus mg, so here the sum of forces equals to T minus mg. We divided by m, because here we have this formula, sum of forces over m. So when you divide this sum of forces, T minus mg over m, you can, how math works is that in the fraction, when you have a minus or plus in the numerator, you can divide each monomial by the denominator. So how many monomials do we have? We have first monomial, second monomial. So you enter this m, which is in the denominator, on the first and on the second. So a equals t over m minus mg over m. Clear? And then here we have a times between mg. So we can easily delete the mass, because mass is always constant. Wherever you go, wherever you come, your mass is always constant. So you can delete, because it's of course a number, 5, 4 minus 5, 4, 6, 7, whatever. So we will end up having T over M minus G, which is letter A. Let me make sure that you understood. Clear. Bravo. Clear, clear. Okay, perfect. Okay, let's continue. We do now the question. Let's do this is the last. Okay, let's do just 58 and this page and 58 and we're done. So we're done for today. Everything else like we do it later because today we did so much. I think your head cannot hold more. So let's see. We have to find x, the value of x. 8 to x plus 3 over 1, whatever. Okay, let's do this. So 8. No way. Okay. 8 to x plus 3 times 1 is the same. Over 4, 3 power x equals 2x power 3, x plus 3. And then 8 is 2 power 3. So 2 power 3 into 2x plus 3 over 2 power 2 into 3x. I'm just trying to simplify 2 power x plus 3. So 2 power 6x plus 9 over 2 power 6x equals to 2 power x plus 3. Now, if you come to this here, you find out 2 power 6x plus 9. So this can be divided into 2 power 6x times 2 power 9. When you have the same base, you can add the powers. So we have a times between them, and we have 2 power 6x up and 2 power 6x down. So we just delete them. So 2 power 9 equals 2 power x plus 3. This means that 9, because we have the same base, so 2 and 2, so 9 equals to x plus 3. So 9 equals x plus 3. X equals to 9 minus 3 equals to 57. 39 male students and 36 female students were asked how many meals they had eaten in the school cafeteria, whatever. So we need the mean number of meals eaten. The mean number, the moment you see mean means average. Average is the mean. So we have the mean number or the average number of males that 8 is 2 and the average number of females that 8 are x. And all the students together is 3, 1 over 5. So what do we do here? Number one thing, we have to try to write this as a normal whole number and to write these as normal whole number. Now let's focus on this and then later we do this. So 3, 1 over 5. How we do this? We multiply by the denominator and we add by the numerator. So memorize this. It will end up 3 times 5 is 15. Plus 1 is 16. And we divided by the denominator, 16 over 5. Let me give another example. This one, let's say 4, 1 over 2. 4, 1 over 2, here times, here plus. So 4 times 2 is 8. 8 plus 1 is 9. And then we divide by the same denominator, 9 over 2. This one. 4 times 5 is 20. 20 plus 2 is 22. And then we divide it by 5. 2 times 5 is 10. 10 plus 3 is 13. And then we divide it by the same denominator, 13 over 5. 4 times 3 is 12. And then 12 plus 2 is 14. And then 14 over 3. And then 3 times 5. 15, okay, 19. Okay, so you knew now how to solve this kind of things, which comes like in this way. Now we're gonna go to the question. Let's do this. So 16 over 5, this one. So now we need the mean. The mean is the average. So what do we do to find the average? Let's say you are at your school and you want to calculate your grades in school. You come, you be like, okay, math, I have 15. So you multiply the math by the number of subjects you have, right? Here the same thing. You multiply the average of the males by the number of males. So 39 times 2 plus. The females are x and the number of females is 36. 36 times x over the total of them means 39 plus 36 equals the average of all students, because here we have males and females, and here males and females. And here the total or the students equals 16 over 5. And then we end up with a 78 plus 36 x over 75 equals to 16 over 5. We do the cross multiplication. We end up by x equals to 4.5 or 9 over 2. 4.5 is the same as 9 over 2. Who from these was 9 over 2? Was the first one, so the answer is A. And now we have the last question for today. Let me make sure you don't have questions. The part. Okay, perfect. I will do this. So the base is the same. Okay. Look, Sayed. If you have two, okay, let me just edit. So if you have a 2 power 3x plus 4, it is the same of 2 power 3x times 2 power 4. Because when we have same base and they are multiplied, we add the power. Let's say you have a 3 power x plus 1. It's the same of the 3 times 3 power x. Because same base, so it's 3. Here the power is 1, so 3 power x plus 1. So you should just know this kind of basis, that when you have the same base and different power, you just add the powers. When you have a multiplication, you end up adding the powers. And in that kind of question here, what did I do? It was 2 power 6x plus 9. So I just divided it 2 power 6x times 2 power 9, which is the same as 2 power 6x plus 9. But why did I divide it? Because I found that up we have a 6x and down we have a 6x. So what did I want to do? To eliminate the down, so I make it easier. To eliminate the big things to make it easier for later. Okay? Let me make sure you understood. Okay, Sayed, did you understand? Perfect, welcome. Okay, let's do the last question, which is this. Okay. So they said a beaker contains 1,000 grams of liquid that's stirred at its boiling point. A 100-watt electric heater is completely immersed in the liquid. The heater provides the liquid with thermal energy, and 200 grams of the liquid changes to vapor in 1,600 seconds. So we already have everything in the unit. So what's the specific latent heat of evaporation of liquid? So we spoke about latent heat today. And I gave the formula of the latent heat, and that's why I wanted to do this question. So the latent heat formula that I gave today morning is Q equals to mL, the mass times the latent heat. The energy is mass times latent heat. And as we know that the power equals to energy over time. So these are the two formulas that we should know. So first we have to find the energy, and then energy means Q is the same. Okay. So we find the Q from this equation, and then we find the latent heat from this equation. So power, which is the watts one, is the 100. So 100 equals Q over 1600. So Q equals 160,000, okay, joules, because it's the energy. And then we have to find the latent heat. So the latent heat by crisscross or by triangle formula, L equals to Q over M. Q, we already have it. It's here, 160,000. Now, what is the trick in this question? They gave you two masses. The first mass is the liquid, and the second mass is the liquid after changing to vapor, the water vapor. So here they want you to fall in this trick and to use this mass. But you should put in mind that you always use in the latent heat, we always use the produced mass, the last mass, the produced mass. So here, what did they do? They just put two masses for you to fall, but a person should know that he should use the last mass, which is the 200. So you divide by 200, take off the zeros. 1600 over 2 equals to 800, which is this. Okay. So I don't know if you guys understood everything. Anyone have any question, please tell me, because I'm done. So just tell me all the questions you have. No. Perfect. Guys, all interact. I want to know if you have any questions, if everything's clear, if I'm speaking fast. You're welcome. Perfect. So tomorrow, I think it's at 9 a.m. At morning is the stoichiometric solving. We'll be solving tomorrow at morning. And then it will be, so it depends on my work because I work outside this thing. So I'm gonna tell you after some time, like after 2 hours, the timing of tomorrow, okay? And of course, as you see that anytime I feel I'm free or I feel I don't have like so much things, I try my best to solve with you things or to add things because I really want you guys to succeed and I really like take it serious. I'm trying to do this and to solve with you, especially we are still in the introduction in the beginning and no one solves from the beginning, nothing. But why am I doing this? I want to put you in the nature. I want to put you in this like scaring nature. Oh, the Imat is so soon. We're solving from the past papers. So I want to put you in this nature. So that's why I try to solve from the beginning. Like I'm just giving you from the beginning, solve this in this way. Because you really have to be the nature. We're really so soon. It's in 17th September. And yeah, register guys and really like I really want you to focus and yeah, you all will be doctors soon, inshallah. Okay, did I stop screen sharing? No. Okay, perfect. Everyone is okay? Perfect. So now we will close the meeting. Have a good night and do your assignment for tomorrow. Don't forget. Buona serata. Bye bye.